Hello, one and all in Cyberland. That suddenly makes me think of Lunch Lady Land. Sloppy Joe, sloppy Joe. Okay. We're just gonna have two examples of solving for a variable with more than one step. Okay, so we are going to read this equation. We're gonna do this one first, right? So what are we looking for? We are looking for this thing, right? We are solving the puzzle that is this, and we are told some basic information. 3 times whatever we had, taking away 6 got us 9. 9, countable 9, is the same as this. They're the same thing. So, like a puzzle, we're just going to undo everything until we figure out what this is. Now, could we intuitively figure this out, right? This is like going back into the realm before Al-Khwarizmi's method, right? When Fibonacci and others, merchants and things, they were just thinking about this stuff. They were thinking, well, 3 times something, take away 6 is 9. What is the difference of that? Well, let's see. What are 2 things that the difference is 9, right? Because difference is subtraction. So let's see. 18 minus 6 is 12. No, that's not going to work. 15 minus 6 is 9. So 15 minus 6 is 9. Is there a way to make this 15? Well, 3 times 5 is 15. I'm pretty sure x is 5. And x is 5. And that's how things used to be solved. But again, we're practicing an organizational method for when things get hard. Okay? When they become so difficult you can't just ponder and put back in your brain. Okay? So, yes, 15 minus 6 is 9. The difference between 15 and 6 is 9. And 3 times 5 is 15. Boom, done. We're going to get to 5 also. But let's just show how we do it with inverse operations. Okay? Because the key to everything in life that we do, okay? So inverse operations is something that humanity has been doing for almost 1,000 years. Based on this idea of this thing is the same as that. So let's get to it. I know you're like, Becca, we could just do this right now. Why did we waste all the time? It's not a waste of time. Learning is never a waste of time, nor is me pontificating. Okay, so I subtracted 6. To undo that, I am going to add 6. 6 equals 6. That's the whole thing. This dashed line that we're calling our balance line. Thank you, Alexis, for telling me that. Everything on either side is always equal. Okay? So over here, we get the identity. Anything minus itself is 0. Right? It's a twist on that idea that I said, what number can you add, and you'll have the same number, right? So this comes down, this is 3 times x, right? Remember when you have 2 numbers butted up against each other, that's a multiplication, equals, now what is 9 plus 6? We've already done this in our head, right? It's 15, okay? 15. And now, we also already did this in our head. We're going to do same operation. So 3 is multiplied by x. So to undo it, we divide, right? You opened the door and now you have to shut it. You turned off the light and now you have to turn it on. Just inverses. So now this is the identity. Anything over itself equals 1. We are looking for the identity constantly. The identity of 0 in the additive, the identity of 1 in the multiplicative. Okay? Yeah, I know I just use big math words. All right? You can too. I'm using them because you are now on the journey of discovery, and I'm giving you new vocab. All right. So over here we have x, because anything over itself is 1. 1 times x is just x. We don't write the 1. 15 divided by 3 is, we already talked about this, it's 5, right? I have 15 Skittles. Finally figured out a use for these jelly beans that I got that are not the good ones. I have 15 of these. I divide them evenly in 3 piles. Each pile has 5. We'll do that later. X is 5. We already knew that, right? Because we went on a journey in our brain, right? Right? But now this problem is more complicated, isn't it? Isn't it? Isn't it? You will assimilate. No, okay. All right. So, because what do we want to find? We want to find x, right? But where is x? X is here, and x is there. And where is our equal sign? I'm cutting off my own head. I'm cutting off my head to spite my face. Okay, balance line. We have an x on one side of the equal sign, and we have an x on the other side of the equal sign. Can we do inverse operations to solve right now? No, we can't. We can't, because x, our variable that we need, is in two places. It's in two places. It needs to only be in one place. One place. Okay? Now, when we get way further along, we learn about factoring, and we can solve things in more complicated, but that's a different thing. You still are doing one at a time. One at a time. Everything is counting. You simplify everything. Okay, we cannot solve this yet because x is in two places. So how do we solve it? We need to, wait for the phrase, combine like terms. How do we combine our x's across the equal sign? Well, we combine them the same way we did the other things, but now we're dealing with x. So we're not solving for x yet. We're getting it in the same spot, okay? So this is like old school PE class, all right? We can either move the 2x or we can move the 5x. It all depends on what you want to see, okay? So in one side, our variable will be over here. Let's do it that way. So on this side, they're going to scream, Red Rover, send 2x's right over. And then 2x is going to be like, here I come. But what operation do we use to get them over there? There's nothing written here. So that means it is positive. That means it was, in theory, added. And adding means to undo it, we subtract. So, Red Rover, sent 2x right over. I don't know what the point of that whole thing, except for it always felt really nice to have your name called. Didn't it? It felt good. I thought so. Truth be told, I didn't get my name called very often. And when I did, it was like, so let's all be fair to each other, right? No one wants the COVID-19 to call their name. So that's why we don't open the economy yet, okay? Or open up our society. Our economy's always open. That's what people don't seem to get. We're always open. The world is the city that never sleeps. Okay, I digress again. Oh, Rebecca. Okay, so what happens over here? Just because it's an x, there's an x involved, doesn't mean that it hasn't become 0, okay? We don't need to know what x is to know that whatever we had, we got rid of it, okay? We don't need to know that. It's 0. Anything subtracting itself is 0. It's the additive identity, and that's what we wanted. So 0, we could write it down, but we don't have to. I'll write it just so we know. So what happens here? Do we write 4? How many of you guys out there are like, yeah, that's right? And how many of you guys are like, no, stop, you're screwing it up? If you're in the, no, stop, you're screwing it up camp, you're correct. Because what did I forget right here? Do you see it? So this became 0, and this is 4. But what happened here? What was that? Oh, we don't need that. Yes, we very much do. 4 was subtracted. So when we decided to get rid of this thing, it didn't suddenly make 4 positive. 4 was still taken away, so it stays negative. So now I'll get rid of the 0. We have negative 4 over here. Okay, I could just do this, but that would, my hair is not looking very good anyway. Let's be real. So it's just the Mac is doing me a favor. Okay, equals. Now we do this. Let's get rid of this little arrow because it's a little confusing. 5x minus 2x. Okay, again, we don't need to know what x is to know that if we had 5 of them and I took 2 away, I have 3 left, right? I don't need to know what makes up my weird Skittle or jelly beans that are apparently like cola flavored, which I totally screwed up. Sorry, Easter Bunny. But I don't need to know what makes them taste like that. I just know that if I have 5 of them and I take away 2, I have 3 left. Okay? Same thing. I don't need to know the contents. I'm not creating jelly beans right now. So I have 3 whatevers. And again, this comes down. Plus 8. Now our equation is negative 4 is equal to 3x plus 8. All right. Let's ask ourselves again. is our variable in one spot? Well, there's no variable here. And over here, it's exactly in one place. So the answer is yes. Okay, so inverse operations. I want this by itself. I could divide everything by 3 first. I could. I've had students many times before say, divide by 3, and I could. And I'll just talk you through it. I'd get x plus 8/3 is equal to negative 4/3, and that's fine. And then I'd subtract 8/3 from both sides, and I'd get negative 12/3, and I'd find out that that's negative 4. Or excuse me, negative 4, 12, yeah, that's what I'd end up with, right? Yeah. But I don't want to do it that way because that gives me fractions. I would go into the realm of rational numbers and come back out into rational numbers. I have integers here, so I want to leave it as integers because most people just like to count in whole parts, okay? So I'm not going to do dividing by 3 first, but the reality is you can do anything you want, anything, so long as you do it to both sides. Now, I would recommend not multiplying both sides by infinity because it would gobble up all this stuff and then you just have infinity equals infinity and you would not figure out what x is. But you can do anything you want, right? Every single day that I'm in my house, I choose to go out of a door. I have a back door, I have a front door. Could I break through my window and go out that way? I could. Could I take the sledgehammer in my garage and just pound a hole in my wall? I could. It would get me from inside to outside. It would. Would it be useful in my larger sense of what I'm doing? No, it wouldn't. So that's why I don't do it. So I can do whatever I want to this, but there are like useful steps. And the first useful step is what? Subtracting 8. Again, negative 8 equals negative 8. Maybe I should just finish this problem and quit going on sidebars, although it would be really weird to go pound a hole in my wall. So we get 3x over here, and 8 minus 8 is 0 again, right? Now, what happens here? We might need our number line, right? Let's just do a quick sketch to make sure we're going in the right direction. Here's 0. 0, and then I went negative 4, right? Here's the negative direction. Oops. Here's the positive direction. And then I went negative 8 more. So now I know that I became more negative. So I can just think of 8 and 4 together, and 8 and 4 is 12, but it's negative 12, right? And now, much like here, I'm going to divide both sides by 3. I got to move this now. And over here I get x equals, and negative 12 divided by 3. Again, you can just know my answer is going to be negative, because I have one negative divided by a positive. 12 into 3 parts. If I had 12 more of those jelly beans and I divided them evenly 3 times, what do I get? Negative 4. Now, Miss Becca, Miss Thompson, does it matter that my x is over here? I said negative 4 equals x. Should I say, is this the right answer? X equals negative 4? Is that what I should write? And I'm here to tell you it doesn't matter. You are stating inequality. It's like looking in the mirror. Except for, well, maybe we're in the world of Alice in Wonderland. X is negative 4. Negative 4 is x. That's all that really matters in that regard. Oh, gosh, I'm wearing a lot of, like, running things a lot. Like, I didn't realize I was that into running until I realized that almost everything that I own is about running. Okay, those are two examples. One had 2 steps. One had 3. I know I went on some sidebars. That's what makes math fun. But just know that's what's going on. Math way too often is about formula. And it is, and it can be, and that's the method, right? But we solve problems every day, all the time. You solve problems every day, all the time. As I tell my students sometimes when they say they don't get math, I say, do you know what complex problem solvers you are? I said, okay, let's say that this bus line is down and you have to get to work. What are you going to do? What do you do? And kids tell me all the time, well, I'll take this bus line instead. And I said, see, I don't know any of that stuff. Or they'll say, well, I can do this thing, and I can take this to there, or I can walk to this different line. You all know how to solve problems, okay? Math in algebra is just a very specific way. Now, if you could train your brain to think that way, Okay? You can be, that's just the way I see it. I see it as mental confidence, the same way that the more I run, the more I get physical confidence. That's just the way I view it. So, oh, sweet Lord, I'm at almost 20 minutes. And 20 minutes with, like, looking terrible. So, yikes. See you later. Stay safe.